So when I insert this battery, we're going to go quite quickly because this machine is going to do 54 automatic self-tests. The first bunch of tests all the way up to about 14, 15 are internal computer tests. So they're RAM, ROM, EEPROM tests. They're making sure the computers can all talk to each other. They're making sure the solenoids draw enough power. So they're all internal checks. Then you're going to see a few checks happen. You're going to see the backlight light up to check that the backlight works. You'll see the light at the back of the rebreather light up. The the hood will light up red, the hood will light up green, and it will test the buzzer. What it's doing is it's putting power to all of these components and checking that the voltage draw is right to assume that they're working. So it goes through and checks every part of the rebreather. It'll then ask us to manually step in from time to time. You'll hear it beep and say, please step in. It might ask me to open the cylinder valves, to change the mouthpiece position, and it's going to go through its startup check. One of those checks is to calibrate, and during its calibration process, it'll also confirm that I've got the gases that I said I'd have. On the one side here, you'll see the test number. If it fails, over on the other side, you'll see the failure number. So we've got an idea where we are. Let's start the machine, and we'll see how we go. So in goes the battery. You'll notice the first thing it will do will be a screen test. So now it's turned the display on, and we've test 10 already. So it's done a whole bunch of tests already. We can see our battery voltage at the bottom, and we can see our little bubble man. That's our no dive man. So it's a little face with bubbles saying don't breathe from the rebreather. We're at test 16, and things will start to light up now. So if we're going to look at the hood, there's the backlight. So that's the backlight test 17, test 18. Red on the hood, look. Green on the hood now. Red on the back, you see my hand through the back there. Then, in a minute, the hood's going to vibrate. You might be able to hear it. And now, beep, beep, beep. That's our alarm, checking our alarm's working at the back. And the machine's asking us to do something. What's it asking me to do? It's very simple. I can see it here on my display. It's saying CC. So I'm going to move this mouthpiece from this position to this position. What it's doing here is it's making sure that there's no volume inside the loop. A little bit later on, it's going to inject gas. If there was no scrubber inside the machine, the amount of gas that it would see when it injects would be greater. So it can detect a little bit whether there's a scrubber installed or not. It's not a perfect system, I'll be honest with you, but it is a way of checking. We've also got a manual here, look. CANISTER. It's reminding me, have I fitted a canister of softener lime inside, or is there time remaining? I need to manually lick my fingers and touch the two wet contacts. If I touch those two wet contacts, I've confirmed that there is definitely a scrubber in here. So I'm going to touch those two wet contacts right now. It's going to log that into its like black box data recorder for later on. You can see the progress of my touching the contacts is complete. Now we're on test 43. Test 43, it's asking me to go to open circuit. I'm going to move the machine to open circuit because it's going to do its next test. And its next test is a positive test. You'll notice when I did my negative, I didn't do a manual positive. I didn't blow the rebreather up and check it. It's going to do that itself. And it does it in two ways. First thing it's going to do is it's going to inject oxygen to a low pressure. And then it's going to see if that low pressure stays. It's using the two metabolic solenoids to inject oxygen. If they then shut and the pressure does not rise using a very sensitive sensor inside, it knows that those solenoids shut correctly and the solenoids are not in a stuck open position. That's an automatic feature. It'll then inject oxygen again to blow the rebreather to an even higher pressure and do our actual positive test. Okay, so I move my mouthpiece to the open circuit position, and as you can see, the machine detects that automatically. I don't have to tell it by a set of buttons. I move from open circuit to closed circuit. It knows by the switch on the mouthpiece whether I'm in open circuit or closed circuit. Test 44, and you can see it on the screen, this machine is very intuitive. If it's flashing, that's what it wants you to do. So at the moment it's flashing oxygen down one side and diluent down the other side. So it's asking me to turn the gas on. I'm going to turn on the oxygen, again, nice and slowly. And you'll see the oxygen pressure will rise. And then I'm going to turn on the diluent. Because it's a Poseidon regulator, expect it to make a noise. That's a downstream regulator filling up. Upstream regulator, sorry, filling up. And I open both tank valves all the way. Now you can see the machine injecting. It's injecting and blowing itself up to that low pressure, and then it's going to stop the two solenoids. Those two solenoids are going to stop. When it's stopped, it's going to check and level off. If that pressure remains constant, we know for sure that our solenoids aren't leaking. So we just wait. If I was to compress the countertones or squash the rebreather now, it would fail this test because I'm increasing the pressure inside the loop, and it would detect that a solenoid's failed. Now it's going to blow itself up again and monitor the pressure for any pressure drop. Because it's blowing itself up to high pressure, if there's a small leak in the counter lung and it starts to leak out, it would notice that as a pressure drop, and then it would fail based on its positive pressure test. Again, if I was to press the rebreather here, the machine would fail. Now that's okay in this nice environment. If I'm doing this on the way out to a dive site on a bumpy rib, then I could potentially have a bit of an issue with this test. Hopefully I've done it before I've got in the rib, but you want to make sure the machine is ready to go when you get there. If it was damaged during the process, that's not ideal. So next step, now it's past that test, we're on to test number 50, and test number 50 is asking me to go to closed circuit. It's asking me to go to closed circuit, like the other rebreathers, so that oxygen as it's injected for the calibration process can exit the rebreather. If I let the oxygen just build up as pressure, I'm going to get increased oxygen pressure, and I've got a high fraction of oxygen, so I'm going to get an increased partial pressure. So that means the calibration will be wrong. Like the other rebreathers, I could accidentally have it closed and calibrate badly. This machine won't let me calibrate badly because it won't calibrate at all until it knows that the mouthpiece is in the right position. So again, another interlock to keep you safe. I open it into closed circuit position, it detects that, and test 53, it's going to start to inject gas. First gas it's going to inject is oxygen. It injects oxygen and takes it all the way up to the highest limit. So it waits for those cells to settle with pure oxygen blowing onto them. Once it's got the highest limit, it says, okay, great, that's what oxygen should be. Based on oxygen, I'm now going to inject diluent at a lower limit, and I'm going to check that that is 21. So if that was oxygen and that was 21, are they the difference that I expect to see as well? And so that way it can confirm whether the gas you put inside, the calibration was correct. So you can hear it now injecting plenty of gas to do the high calibration. You'll hear a stop, then you hear another type of noise, and that is the diluent going in. So oxygen was first, now it's adding diluent. And you can see our little progress indicator on the top, just letting us know where it is in its tests. So it's injecting gas, and then I just heard psh, which is the one of the oxygen solenoids fire, and that means that this test was passed successfully. And in a second, when it's done its calibration and set all the computers to oxygen, it's going to say, okay, great. Now test 54, please go to open circuit mode. So again, I go to open circuit. It detects that, and it says B-R-E-A-T-H-E, breathe. It wants me to test that the bailout valve is working. So I'm going to do a manual test. I need to breathe 1 or 2 bar from the cylinder, so it recognises the high pressure drop, and it'll also recognise that that's working. Test 55 tells me my weeks to service, and test 55 said 105 weeks. So it's got 105 weeks until this machine needs a service again. And it says PBR 300. PBR stands for please do a pre-breathe for 300 seconds. So a 5-minute pre-breathe. It's asking you to do that. Above here you can see 0.7 is what's inside the rebreather right now. So we're at 1 atmosphere, 0.7, so 70% oxygen inside the rebreather. It'll then flash, say OC, because the mouthpiece is in the open circuit position, and then it flash 0.4. So the set point currently is 0.4. The machine is trying to achieve 0.4. The actual oxygen inside the rebreather is 0.7. Because the rebreather, the amount of oxygen inside the rebreather is 0.7, it will just sit there forever. If I was to start breathing and bring that oxygen content down, the machine will get to 0.4. As soon as it drops below, it will manually inject oxygen to keep it up at 0.4. Okay? If I move the mouthpiece into the closed circuit position, what you'll see is that this now will change to CC. It's changed the set point to 0.5 because it thinks I'm going to go diving. And you hear it inject gas. And I've got CC now, so I'm in closed circuit. Okay, that's really fantastic because I know which position I'm in. If I was to go into the middle here and not really in any position, you can see that my hood just lit up and I got a vibration, and now I've got an alarm, and it says on the mouthpiece, on the handset, NC, no circuit. So that means I'm not in closed circuit, I'm not in open circuit, I'm in the wrong position. So I know that I'm getting an alarm. I'm getting a red flashing light here out the back, and now, because I've left it too long, I'm getting problems. What's happened is I've exposed the loop to air, and so the PO2's come down to 0.21. And now I've got constant beeping, flashing from the handset, from the hood, vibrating, beeping at the back, big red flashing light from my buddy, and it's telling me, bail out, bail out, bail out. So touch that back to the closed circuit position. The oxygen's come up a little bit inside the rebreather because it was ejecting, and now it's happy again.